Hello, welcome to our new media room here at RIPE NCC office in Amsterdam. I'm Ondrej CALETKA, and today I'm going to talk about the need to transition to IPv6, which would be yet another motivational talk about IPv6. I believe you already heard a lot of them, so I'm going to add one more to the pile, and let's see if I try to motivate you to finally do some advance with IPv6. So, first of all, we have to talk about whether we are there yet, because IPv6 has been here for 20 plus years now, and there has been some events like World IPv6 launch in 2012. The IPv6 support is steadily growing. The stats are growing all the time. You can see now the very famous Google graph, which is showing now about 30%, 35% of accesses over IPv6. Every major operating system supports IPv6 out of the box, so this is not an issue anymore. The problem here we are facing is that still majority of internet uses only IPv4, and if IPv6 is deployed, it's usually a second-class citizen. That means that if there is problem with IPv6, the problems gets resolved only much more later than if similar problem happens with IPv4. So we are still not there yet. We still have a lot of work to make IPv6 working properly, and that is why I want to motivate you a little bit and tell you some advantages about deploying IPv6 that you can see even right now. But we cannot start talking about IPv6 without talking about IPv4, because the scarcity of IPv4 was basically the reason why IPv6 was deployed in the first place. So let's talk about the future of IPv4. The future of IPv4 is very bad, I would say. Well, it was started already in 2012 when RIPE NCC entered so-called depletion phase. We have the last 16 million of IPv4 address, and we switched the allocation scheme in a way that we allocate only fixed amount of IP address. Back then it was 1,000 IPv4 address to every LIR. And even with this, let's say, radical saving measure, we still depleted our stock of IPv4 completely in 2019. So in 2019, briefly, there was literally nothing in the pool of RIPE NCC. So what happened then? We actually developed a waiting list. There was a waiting list for IPv4 addresses, because IPv4 addresses get some of them get returned to us as a registry, and if we get these addresses returned after some period of 6 months, it can be reallocated again to someone else. And for this reallocation, we set up this waiting list. You can see that the waiting list at the beginning got some of queue, but then quite a lot of addresses have been returned to the pool of RIPE NCC. So right now there are some addresses in RIPE NCC pool, and the waiting list is therefore empty. There is also IPv4 transfer market, and most companies that are in need of IPv4 are now actually going to the market and basically buying address or getting IPv4 address transferred from other parties for money. The prices on this market are not regulated in a way, so they are steadily growing as the scarcity is becoming a bigger and bigger problem. And of course, there are big players with lots of money that are buying large blocks of IPv4 resources. We have some cases in the history where big blocks that used to be allocated for some, let's say, experimental uses have been reallocated, or actually sold to other parties. Also, like big universities like MIT sold a significant part of their IPv4 space to commercial providers, to big players on the internet. So big players can solve the issue of scarcity of IPv4 with money. What about the others? Well, first of all, let's talk about whether you need an IPv4 address. Well, unique IPv4 address to be precise. The thing is, if you are a home user, well, probably not, because there has been already decades of home networks deployed with only public IPv4 address on the outside interface of the home CPE, home router, and then inside the home network there were always private addresses, and there was also always NAT. So if we just extend this scheme in a way that we deploy carrier grade NAT, and there would be another layer of translation, in reality this works for the majority of home users. So as a home user, you probably don't need to consider IPv6 or need of let's say public unique IP address, no matter whether v6 or v4 at all. Well, but if you are an enterprise, the situation is a little bit different. As an enterprise, you definitely need an IPv4 address, probably several of them, but at least one, because you probably have some kind of VPN on site, and you want to have this VPN or other services accessible from the whole internet. So therefore, you need an IPv4 address. If you are a colocation provider, or let's say a virtual private service provider who is providing servers to customers, or some kind of cloud computing provider, then the need of IPv4 is a big for you, because of course every single customer of you will probably need at least one unique IPv4 address. So, and this is very competitive market, so you cannot just like put the price of the IPv4 address into the price of the service, because then the service will get like cannot compete with other offers on the market. So if you are a colocation provider or housing provider or hosting provider, you probably already are facing the big issue with scarcity of IPv4. The bad news here is that this is not going to get better anytime soon, because we will still need IPv4 unless IPv6 is deployed universally. And universally here doesn't mean 100%, but it does mean that anyone who needs IPv6 can obtain it, which is not the case today. So you still need some IPv4 address. You still it will still last some years to this need, but still, if you deploy IPv6 early, well, now it's not early. Now it's already like the early adopters already have it for years. But still, you can save some IPv4 addresses if you run the most of the infrastructure IPv6 only. So that's the thing. That's the thing you can actually save you some scarce resources. Another advantage is of deploying IPv6 right now, not waiting after you are forced to do it, is that with IPv6, it's the only way forward that your services can grow. If you have IPv6, then it means you will never have to face again the problem with scarcity of IP address. You can put IP address on anything you need, and you can plan in advance large blocks of address for specific purposes. Also, if you are an ISP, for instance, and you of course, you have to solve issue with IPv4. You probably already have carrier-grade NAT, but if you deploy IPv6 alongside with carrier-grade NAT, the carrier-grade NAT will get less strain because lots of popular services, especially those like with significant amount of data, let's say YouTube or Facebook, are already available over dual stack, so over v6 and v4 at the same time. So deploying v6 means that the traffic to those services will go around your carrier-grade NAT, and carrier-grade NAT will have less work to do. That makes it less strained, and that means you can afford a cheaper one. Also, sharing IP address, no matter whether v4 or v6, is problematic with some issues like geolocation, for instance, especially with IPv4 address that are from the market that have been used before in some other country, perhaps. There is quite a big issue with geolocation databases that are scattered all across the world, and those geolocation databases are not always up to date. So then your users have problems that seeing web pages in strange languages, or being blocked from some web pages because their IP address is not from the right country according to the service provider. Another problem is with block listing and rate limiting. So for instance, if you have shared IPv4 address, you probably cannot use it for sending outgoing mail because behind the same IPv4 address there will be other scammers or spammers sending unsolicited bulk email, and that therefore the address will be blocked. With IPv6, the data retention is also simpler because you can address statically everything. You don't have to keep records per each session, per each flow, like you do with NAT, because each flow is by different individual user, but you have actually just a static table, which address is assigned to which user, and that is it. And last but not least, you will save yourself from problems of colliding private address range, because with IPv4, there are just a few private address range, and those private address range are reused in every single company, I would say. So once there is a merger and acquisition between two companies, very likely those two companies will operate an internal network that will use exactly the same set of IPv4 address, and trying to solve this issue in order to have access from former A company to former B company using the same set of IPv4 address is pretty big nightmare for IT personnel. So, did this convince you to deploy IPv6? Well, then let's see how you can do it. What we are trying to say here is that you should deploy IPv6 in a future-proof way, so in a way that you will not need to redeploy it or reconsider your deployment after some years. So first of all, you should start with proper addressing plan, that you should start from scratch. You should not just reuse already existing IPv4 address plan if you have some, because usually the IPv4 address plan is full of full of quirks that are made just for the reason of scarcity of IPv4, whereas in IPv6 you don't have to spare addresses. You can reserve enough space for future growth. You can group prefixes systematically by function, by location, by security policies. And this actually will make the IPv6 address much more readable and much more easily memorizable than even IPv4. Some people say that IPv6 addresses are just too long to remember, but if there are hidden meaning in the digits there, like that there is function, there is location, and so on, then you can easily actually remember even quite a long IPv6 address, and everything will start making sense. Another tip we have here, please deploy native IPv6. Don't ever think about deploying some kind of tunneling of IPv6 over IPv4, because think of it that IPv4 should be eventually turned off. So whenever your IPv6 depend on IPv4, that means your IPv4 will have to stay forever. Another tip is that you should consider using a transition mechanism for IPv4. Well, the well-known and the most commonly used transition mechanism for IPv4 is called dual stack, which is basically running IPv4 alongside with IPv6. But that's not the only transition mechanism. There are others that will allow you to run significant part of the network IPv6 only, and therefore again save money on extra cost of IPv4 resources that might not be needed at the moment and will not be necessary in the future. Also, every time I talk about IPv6, somebody mentions that it should have been just an extension of IPv4, that is too complicated, why they deployed a new protocol. And I was thinking about answer for this, and the answer here is that even a minimal extension of IPv4 would mean incompatibility. Even if we just change from 32 bits, which is the IPv4 address, to let's say 33 bits or 35 bits or 36 bits, it will still require upgrade of every single IPv4 system to be able to speak to the new address space. So in that matter, it sort of doesn't matter whether you just extend it like IPv4 in this way or you just build a new protocol. And one thing to add about IPv6 is that IPv6 provides some solutions to problems that inherently didn't exist in IPv4. For instance, in IPv4, nobody ever, as far as I know, solved the issue of addressing home networks with public IPv4 addresses. Every time you have a home network, you have a CPE which performs NAT, and you have private addressing at home. But if you want to have globally unique addresses at home, somehow those addresses has to be provided, and there has to be routing information in the network all the way to your home network. And that's something that is not solved with IPv4, and it is solved with IPv6. So, and that is one of the reasons why just having IPv4 extended with a large address would not solve the big issue we have with lack of end-to-end connectivity and end-to-end principle of the internet. Another thing people are usually concerned when deploying IPv6 is security. So let's talk briefly about security aspects of IPv6. First of all, we have to say that IPv6 is neither more nor less secure than IPv4. It has some vulnerabilities just like IPv4. It has some new issues that IPv4 didn't have, but some issues of IPv4 are also solved. And the most important thing to note here is that global addressing, that means that everyone has a unique IPv6 address, does not mean that there is global reachability. You don't have to, having unique address means that you can be globally reachable, but doesn't mean that you have to be globally reachable. So we still have firewalls, and they still work the same way they worked in IPv4. So we can easily make some globally unique address non-globally reachable if we want to, but we can always make it reachable. This is the main advantage of IPv6. Some protocols that are supporting IPv6 are new, especially like neighbor discovery and things regarded to local networks with IPv6. And of course, these new protocols are different than in IPv4 and have different vulnerabilities. So here, the best security feature is always knowledge. And as a shameless plug, I would like to point you out for our brand new e-learning course on IPv6 security that you can try for free at academy.ripe.net. So give it a try, and maybe you learn something new about IPv6 security. Going to the future of the internet is IPv6 only. So deploying IPv6 is the first step, but it's not the last step. The last step is actually turning off IPv4, and only after we turn off IPv4 we will finally fix the issue with scarce resource, which is IPv4 address. Because we can release them. The thing is, if you just deploy IPv6, that means you have dual stack, you are running IPv4 and IPv6. The dual stack is very good at masking issues with IPv6. So even though you think your IPv6 is fully deployed and fully working, it may not be actually working, and you just don't see it because, for instance, web browsers now very quickly switch from IPv6 to IPv4 if they find out that IPv6 is not working properly. So only after undeploying IPv4 you will actually find out how well your IPv6 deployment performs. So if you want to start, there are some easy steps to start from. So first of all, usually you have some management network that is accessible only to you via a VPN, and this is a great candidate for undeploying IPv4, because if it's your management network, it shouldn't be accessible from the internet. It's accessible only from your VPN. So first of all, you should deploy IPv6 to your VPN. And once you have IPv6 in your VPN, there is no need for IPv4 in your management network, because you are guaranteed that have IPv6 access every time you access the management network. Then you should continue with your office network or home office in case you are stuck in home office. Very good idea is to, I don't say to everybody, but at least for the tech department, to use NAT64 and DNS64 instead of dual stack. And this way you can actually discover what kind of hardware and software have issues with this setup. That is, by the way, very common in mobile networks. So it's like not something highly experimental. Yeah, and with this, I have last few slides. So first of all, if you are still not convinced, then this graph is for you. It's from IPv4 marketplace, and you can see that the price of IPv4 address rised in last year from about $20 US to something like $55 US, and the graph looks like that it's going to grow still further, pretty steep. So your issues with paying for IPv4 will be probably worse. And also another thing that I wanted to say in the end of my talk is that there is no plan C. Well, IPv6 is the only known solution for the continuous growth of the internet. We really don't have anything else. And considering how long it took for IPv6 to get to significant amount of traffic, even if somebody now deployed a brand new protocol, it will not help us in next 20 years. So really, the only way how we can grow the internet is to deploy IPv6. Good news is that IPv6 is already deployed in pretty large scale, so there are even big players running IPv6, and it works for them. IPv6 only plans are pretty big. We hear about plans from the US government. We hear about plans about IPv6 only from China. So we will see. And actually, we already have first IPv6 only projects. For instance, if you look at the US government, they are actually archiving the old version of websites of, for instance, White House. And as you see on this screen, this web page archival web page of White House is now accessible only over v6. If you try to open this URL over v4, you just get an error because there's no IPv4 address associated with that. Yeah, and with this is my last slide. So I thank you very much for watching this presentation. I will be live here for some questions you may have, so feel free to ask me. And that's everything from me. Have a nice day and goodbye.
Okay, thank you very much, Ondrej, and welcome live to the LUNOG conference.
Hello,
how's the weather in Amsterdam?
Sorry?
How's the weather in Amsterdam?
Well, right now there's the sun shining directly to my window, so I had to cover it to see my face a bit. So right now pretty good. It was raining in the morning, so I would say typical Netherlands, everything.
It's better than here. We don't have the sun over here.
Perfect. So I don't see any questions actually for this presentation, but I still have something to add to the presentation that has been recorded some time before. Actually, there was the amount of LIRs that are starting the. Let's see if you can see it. Actually, you see too much now. But the amounts of LIRs that are starting their accounts is going. So the status of pool, which is on this graph, you can see that last half year is going down, and we actually expect that it will be on zero today or tomorrow. That means that we are going to reopen the waiting list again, and you can call it probably like second wave of IPv4 depletion. So that was my short update.
Good.
About the situation in RIPE NCC. Other than that, I'm not sure whether there are any other questions.
Let me add to what you just said. So the waiting list that you mentioned is accessible only to new LIRs. So you need to open a new LIR account with the RIPE NCC to have access to that IPv4 waiting list. And that is then for free. But the amount of addresses available is going close to zero. And afterwards, it's the waiting list, meaning that it will be replenished with reused or recovered IP addresses, if there are any. So as long as there are no recovered addresses, people have to be waiting on the list. And as soon as addresses are recovered and go out of quarantine, they will then become available on the waiting list. Correct?
Precisely, it's exactly like this. So yeah. And the thing is, of course, like you have no guarantee that there will be a returned address. So even though you set up LIR, you have to pay all the fees, which is like 2,000 euros startup fees plus a yearly fee of 1,400 euros, and then you have no guarantee actually that you get the IPv4 address. But even like, of course, like with current market prices going up through the ceiling, probably people still like think that this is like the easier way or cheaper way to get some IPv4. But we would really like to stop redistributing IPv4, but unfortunately, it's still like people still prefer this, and we are trying to convince them to give IPv6 a chance.
Yes, absolutely. Absolutely. I have a question then to you. You explained a lot about advantages of going IPv6, but when will in fact not being IPv6 start to be a disadvantage or a large disadvantage, a motivating factor for people to move? Because currently you are used to having connectivity either in IPv4 or IPv6. Typically your endpoint is dual stack. So whatever the provider, the content provider uses, your browser will match it. But do you expect that at one point in time, not publishing content on IPv6 will start to penalize the content providers?
I heard some anecdotal cases about this already like a few years ago. It was like, I think it was mostly from Germany. And basically what happened there is that like large internet service provider deployed dual stack light. That means IPv6 only access network with IPv4 tunneled over it. And the part that does tunneling of IPv4 was often overloaded because it was not scaled properly for the needs of the users. And that actually made those service providers that run IPv6 already like an advantage because the IPv6 infrastructure was working, whereas the IPv4 was not. And I think actually this is basically the future of IPv4 networks because they are getting more and more complex and more complicated because of this. And this means that outages will happen on V4 while the V6 will keep working. And probably this is the motivation that will make those content providers that are still ignoring IPv4, IPv6 to actually deploy it. And of course, we also see most of the content providers actually not don't care that much about the networking part because they just use some infrastructure as a service like Google Cloud or similar. And of course, then there is this motivation of the cloud provider. Whereas, first of all, there are some deployments of IPv6 on Google Cloud, which I think will help a lot of content. And second, we can also see some motivation from other cloud providers to actually not use IPv4 unless very necessary because they are actually putting the price of IPv4 into the price of the service. So,
yes.
so these are the things that probably will help IPv6 to go up even more, and even into the case where there would be really like option to go IPv6 only and not lose significant part of revenues or customers.
Yes. Good. Just to add to the topic and to the overall state of IPv6, you mentioned it without naming it. There is what is called happy eyeballs, which is the way browsers try to make sure that the user gets a reply, but that is on top of trying IPv6 first. So in modern OSs and in modern browsers, IPv6 is actually preferred if it works. And happy eyeballs is only there to make sure that the end user gets an about a good experience, even if there is a failure or non-availability of IPv6.
Yeah, actually, I have like a very reserved opinion about happy eyeballs, because first of all, happy eyeballs only work with dual stack. It will switch fast from IPv6 to IPv4, but it's sort of expected that you have IPv6 and IPv4 to fall back. But if you have some IPv6 only transition mechanism like NAT64 or something, then happy eyeballs will not work. And the second thing, happy eyeballs is just like tailor-made for HTTP HTTP operations with very short sessions that can be easily replaced. If anything goes wrong, you just press F5 and the whole web page will reload. But if you run, for instance, SSH session of live video streaming or anything like that, it will not work because it cannot change the protocols during some long-term session. So yeah, happy eyeballs is like, I understand that there was a need for it back in 2012 when it was deployed. It helped a lot people not to be scared of deploying IPv6 and breaking things. But I think it's sort of like time to slowly try to phase it out and rather focus on fixed and working properly IPv6 networks than to like fast switching to IPv4.
Exactly. Like all the other mechanisms that try to make IPv4 continue living, but in fact, we are riding a dead horse there.
Yeah, like right now there are some standards about reopening the 127 dot something that was like loopback, and it's like stupid to have 16 million loopback address where we have paying 60 euros for one IPv4 address, so we could actually get lots of money from selling loopback addresses to people.
Very good, very good. Make people pay for something that will maybe work somehow, maybe.
Sorry, but actually I have to correct myself. Of course, in order somebody's listen to this, I would like to state it clear. RIPE NCC is not selling address. It's not product that we sell.
No.
We just allocate them. We allocate them for free to every one of our members. I just want to have it clear because sometimes I say something like this in a joke and it can get misunderstood.
Good. All right. I have an additional motivating factor to move to IPv6, in fact. IPv6 is the only protocol where you can play games of spellable IP addresses like dead beef, while we were talking dead horses. So that's really the way to go.
That's right.
All right. I see no other questions. Let me check. No. So I guess with that, I have to thank you very much, Ondrej, for your talk and for being with us.
Thank you very much and goodbye.
Yes, thank you and goodbye to Amsterdam.